We want to graph f of x equals the square root of negative x plus 2. So first we want to identify the parent function. So think of this as stripping away the numerical values in the function. So we're wanting to strip away this plus 2 and then also this negative 1 here that's being multiplied by x. And if you strip those away, what's left is your parent function. So our parent function then is just y equals the square root of x. Again, remember, don't just write the square root of x because that's not a function, that's an expression. We want to make sure we write y equals the square root of x so that this is something we could graph. And then we want to identify our transformations. And since we stripped away two different numerical values, we have two different transformations that have taken place. Now, I always recommend that you shift last. So let's talk about the shifting, and we'll list this as our second transformation. And we'll just be discussing order a little bit later as to why we'll do that. But for right now, this plus 2, remember, it's outside of the parent function. The square root actually ends here. It's just the square root of negative x, and then the plus 2 is outside. So that plus 2 is going to impact the y values of the graph. In fact, since it's a plus 2, it's making all the y values 2 values larger. So that's going to be a shift up. Whoa, try again. A shift up 2. Now we want to take a look at the negative here that's inside of the square root. So we have a negative 1 basically that's being multiplied by x. So the negative is inside of our parent function. So think of it this way. We're impacting the x values by multiplying x by negative 1. So think about, for example, an x value of, let's say, positive 3. And what happens if we multiply that by a negative, the opposite of 3? That would give us negative 3. So essentially what's happened here is we just jumped across the y-axis to change from a positive 3 to a negative 3 for the x values. So that negative, since it's inside the parent function, that's a reflection, and it's a reflection over the y-axis. I'm actually going to just write reflect over y-axis. Let me again show you the difference, what this would look like if it had been a reflection over the x-axis. If it were a reflection over the x-axis, then that negative sign, that would be out in front of the parent function. We'd be basically multiplying the parent function by a negative 1. And if that's the case, then you're impacting the y values. Your y values are changing, for example, let's say from a positive 2, that changes then down here to a negative 2, and now you've jumped across the x-axis. So that's what a reflection would look like across the x-axis, but because the negative is inside our parent function, it's a reflection over or across the y-axis. So now let's graph. Starting with the parent function, y equals the square root of x. So we know for the parent function, we cannot have any negative x values inside of that square root. So we are going to start with 0. The square root of 0 is just 0. Then we could go ahead and go to 1. Square root of 1 is 1. 2 and 3, while they work, they are in the domain. The square root of 2 and the square root of 3, those aren't numbers that we can compute easily without a calculator. However, 4 is a good value because it's a perfect square. Square root of 4 is 2. And the next good one would be the square root of 9. 9 is a perfect square. Square root of 9 is 3. So here's our parent function. Looks like half of a sideways parabola. So this would be y equals the square root of x. Now we want to go ahead and reflect over the y-axis. So the point 0, 0, our initial point, does not change since it is on the y-axis. However, our next point, which was right 1, up 1, if we reflect over the y-axis, then it's going to be going to negative 1, up 1. And if I keep going, our point that was 4, 2 is going to reflect and become negative 4, 2. And then lastly, our last point at positive 9 is going to reflect and become negative 9, positive 3. So what I've done here is just the reflection. So if you wanted to label this green graph, he would be y equals the square root of negative x. We haven't done the shifting, but we've done just the reflection. We jumped across the y-axis. So to finish this off, we take all 4 of these points and we're going to just shift them all up 2. So take each point, count up 2, and you'll have your new points. And then I always like to label, which is my final answer. And that looks like my final answer, my function f of x. But of course, we want to be able to check. So again, to check, you just pick any point on your graph. I'm just going to pick this one here. It looks like that point is -4 for x, and 1, 2, 3, +4 for y. So it's -4, 4. So we go back to the original function. The function we were trying to graph was the square root of -x plus 2. So I'm just going to input -4 for x and 4 for y. So when y is equal to 4, we have an x value of -4. And we're just asking ourselves whether this is true. So you can put a question mark over the equal sign and compute this and see, does it give you a true statement? So inside the square root, we have a -4, which is just going to be 4. So we have the square root of 4 plus 2. And indeed, that gives us 2 plus 2, which is 4. Yes, 4 equals 4, so it checks out. So it looks like that our graph is indeed correct. That's a reflection over the y-axis and a shift up 2.